Let's learn how to sketch polynomial graphs, except we're going to take a look at ones that have some variables. On the axes below, sketch a possible function, g of x equals x plus a times x minus b, where a and b are integers, and g of x has a negative y-intercept of c. Label all intercepts. So g of x is equal to x plus a times x minus b. The first thing I need to determine is the zeros and their multiplicities. So I'm going to set this equal to 0 and solve. So I'm going to tee off. So x plus a equals 0, subtract a on both sides, x equals negative a. On the other side, I have x minus b equals 0. I'm going to add b on both sides, so x equals positive b. Now, those are the zeros. Their multiplicities come from the exponents. So there are no exponents, which means that there are imaginary ones. So they both have a multiplicity of 1, which means that they both go straight through. So I'm going to plot my zeros. Remember, zeros are x-intercepts. I'm going to go to my graph, and I'm going to plot a negative a and a positive b. The other thing they told me was that it has a negative y-intercept of c. So down on the negative y-axis, I have a c. You can move these around if you wanted to. So for example, if you didn't want your b to be over here, you wanted it to be closer, you could have it there. Doesn't matter, because as long as you label it, we have no numbers, they're variables, you can choose where to put them. So what degree is this? Well, degree, I add my exponents. So I have 1 plus 1, which gives me a second degree polynomial, or a quadratic, or a parabola. So that either opens like this, or like that. Now, because I have a y-intercept that's negative, it's going to be the one that points up. So all I need to do now is connect all of my points straight through on each of those. So that's my g of x. Remember, if you did this a little bit differently and you had your b moved over, I could have my b over here. Or I could even, let's do this, I could even move my c higher and make my c there. So then when I would connect these, I would have that as my polynomial g of x. And either of those work, because remember, there are no numbers. So as long as you have them labeled properly, you're good. Let's take a look at one more example. On the axes below, sketch a possible function, g of x equals x minus a squared times x plus b. So let me write that down first. Where a and b are integers, and g of x has a positive y-intercept of c. Label all intercepts. So first I need to tee off to find my zeros and my multiplicity. You can take the shortcut here, or you can set it equal to 0 and solve, but if you're using the shortcut, remember it's just going to be the opposite of the factor. So I have x equals a and x equals negative b. So for this one, I have a multiplicity of 2, which means it's going to be a bounce. There's no exponent here, so there's an imaginary 1. So I have a multiplicity of 1. So this one's going to go straight through. So I'm going to plot my zeros. They're x-intercepts. So I have a, negative b. Once again, it doesn't matter as long as you're plotting them and labeling them. And a positive y-intercept of c. Now, my degree, I add my exponents because I'm in factored form. So 2 plus 1 gives me a degree 3, which means it looks like that, or it looks like that. I always like to go with my positive one, so I like to do the one on the left, but as long as you make it match, it doesn't matter. And you got to do the bounce where it's needed. So I'm going to go straight through the negative b, I have to hit my y-intercept, and then I have to bounce off the axis at A. And then I'm going to label it with g of x. So that's how we sketch polynomials with variables.